Well, here's another problem. It doesn't involve gas mileage, but it does involve speed, or I guess I should just say, yeah, speed, not necessarily velocity. So here we're given the speed, how fast this loon is flying. Now, I think that 14 meters per second is pretty darn fast. That's one thing I think. The other thing is, I think, can you think of that speed as being like a property of that loon? So that's not the question. That won't be our first term. That's not the thing we're trying to convert. It says it's flying that fast. How long in minutes? So we're trying to get to minutes, question mark minutes. Okay, oops, M-I-N. Will it take for the loon to fly a distance of 500 kilometers? So the thing kind of specific to the problem, not a property of the loon, not the speed, but something, a specific question, in this case, a specific distance, that's the term we're going to start with. So we're going to have 500 kilometers, and we're going to try to get to minutes over here. Now, I really encourage students to unpack that 14m/s. I should never really see that on a problem written like that. It should always instead be 14 meters per 1 second. Do you see how that translates to that? Well, if that's the case, I can either use it like that, or I can flip it 1 second by 14 meters, whichever works in working my problem. So anyway, do you see a few things? Notice that here I've got distance of meters, 14 meters, and here I have kilometers. So I'm going to have to go ahead and get that kilometers to meters before I can do my thing. But do you see, once I get it to meters, I can go ahead and get it to seconds using this. I hope that I'm going to kind of show you how that works. And then once I get it to seconds, I can get it to minutes using 1 minute is equal to how many seconds? 60 seconds. So that's kind of what we're going to do. So like I said, anytime you see like a 14 m/s, you should be unpacking that as to what that means. It means units. It's all about units. When you set up your problems, it's all about setting up the units right in your kind of fractions or ratios. So it's meters in the top and seconds in the bottom. So for this loon, we could also say in 1 second it travels 14 meters. So we could do what we call the inverse or the flip. We could flatten it out, and one last way to kind of think about this speed of this loon is 1 second is equal to 14 meters for this particular loon right now. So here we go. Go ahead and knock this out. So we're going to go from kilometers to meters, and I kind of showed you why that is. It's because our speed was in meters per second. And you're going to need to know the kilo prefix means 1,000 times the base unit. So you're in good company if you kind of get this turned around, but this is the way it is. 1 kilometer is exactly equal to 1,000 meters. So that's going to be our first. Take that equivalency statement, make a conversion factor following our kilometers. And then we're going to go from meters to seconds using the loon's speed. That 14 meters is equal to 1 second. So at this point we want what? Meters to cancel, be left with units of seconds. Our new units are always in the top, and the units we want to cancel are in the bottom. So then we're almost done, but it asked for time in minutes. So to go to minutes, of course, we're going to use 1 minute is exactly equal to 60 seconds. So I'll just kind of tell you why we're up here. So I'm going to put an X here. There's no uncertainty brought by that relationship. There is uncertainty here. Okay, actually there's 2 sig figs here. That's exact. Okay, exactly 1 second is approximately equal to 14 meters. This brings no uncertainty here because that's by definition. So let's see how we set this up. The first term is going to be that 5.00 kilometers. What, you think 3 sig figs there? Yeah, I do. We'd put that over 1, and then we're going to go ahead and use this equivalency statement to our advantage to go ahead and get kilometers to cancel and be left with units of meters. So it looks like this, 1,000 meters over 1 kilometer. So our kilometers cancel, we're left with units of meters. Next, we're ready to go ahead and go from meters to seconds using this relationship. So we want units of meters to cancel, so they'll go in the bottom, seconds in the top, so we have 1 second over 14 meters. Okay, so meters have canceled, we're left with units of seconds. Now everything is canceled except for units of seconds. So now to get to minutes, we're ready to go ahead and use this last equivalency statement. We want to put units of seconds on the bottom and units of minutes on the top. So it'll be 1 minute over 60 seconds. So now if we kind of take a quick look at everything that canceled, kilometers canceled, meters canceled, seconds canceled, we're left with units of minutes. So in our calculator, the numbers we're going to put in is 5.00 or 5, same thing in our calculator anyway, times 1,000 times 1, divided by 1 times 14 times 60. Okay, so those are our numbers. And again, feel free to go ahead and come up with two numbers, and then, come up with the product of these, the numerator, and put it there, and the product of the denominator, put it there, and go ahead and do one last division problem. So I said above that there is uncertainty only here, okay, brought by the speed. There's 2 sig figs there. Okay, no uncertainty brought here, no uncertainty brought here. There's how many sig figs here? 3. So how would we round this? Round it to 2 significant figures. So it looks like, and again I don't have my calculator value here, I don't have a calculator handy, but 2 significant figures. Notice that we have a trailing 0 after the decimal. That is significant.